Hi students, this is next numerical on diesel cycle. The problem is the diesel engine has a compression ratio of 15 and heat addition at constant pressure takes place at 6% of the stroke. Find the efficiency of the engine. Take gamma equals to 1.4. So let's see how to solve it. Okay, this is the answer. So you can see this is a diesel engine cycle diagram, PV diagram. Okay, 1 2 3 4. 1 to 2 is the adiabatic compression process. This is the adiabatic compression process. Then 2 to 3 is the constant pressure process. This is the heat addition process. 3 to 4 is the expansion process, and 4 to 1 is the heat rejection process. So and here you can see. So this is from this point to this point is V1, the volume. This is V2, this is V3. Okay, and the volume between 1 to 2, that means this is the top dead center, this is the bottom dead center, is stroke volume TDC. This one is BDC, and this volume is clearance volume. Okay, so let's start. The compression ratio R is equals to V1 by V2, and it is given 15. Gamma for air, which is also given, that is 1.4. In the question they have said that the heat addition at constant pressure takes place at 6% of stroke. Okay, so the cutoff ratio RC is equals to V3 by V2. So we can write V3 minus V2 is equals to 6% of Vs. Okay, so that means V3 minus V2 is equals to 0.06 of V1 minus V2. Okay, so or we can write from this relation, we can write V1 is equals to 15 V2. Now substituting the value of V1, that is 15 V2 minus V2. Okay, so that becomes 0.06 into 14 V2. So V3 is equals to 1.84 V2. 1.84 V2, okay, equals to V3. So the cutoff ratio, that means V3 by V2 becomes 1.84. Okay, this is the cutoff ratio. Fine. So now the efficiency, we know that The efficiency formula for an diesel cycle is eta equals to 1 minus gamma into compression ratio to the power gamma minus 1 in denominator. In numerator, this is cutoff ratio to the power gamma whole minus 1 by cutoff ratio minus 1. This is the equation. Okay, so let's put all the values in this equation. 1 minus the value of RC is 1.84 to the power 1.4 minus 1 by 1.4. The value of R is 15 to the power 1.4 minus 1 into 1.84 minus 1. Okay, so the efficiency value comes 0.612. that means eta equals to 61.2%. This is the answer. This is the next numerical. Here the numerical says that an engine working on diesel cycle, the stroke and bore dia of the engine are 250 mm and 150 mm. If the clearance volume is 0.0004 meter cube and fuel injection takes place at constant pressure, that means obviously it's a diesel cycle, that's why the fuel injection takes place at constant pressure. For 5% of the stroke, find the efficiency of the engine. One thing, bore dia means the dia of the piston, okay, which is 150. So let's start. The length L is 250 mm, that means 0.25 meter. D equals to 150 mm, that means 0.15 meter. V2 is the clearance volume, or we can write VC, that is 0.0004 meter cube. So the clearance volume formula you have already know that, pi by 4. Okay, so the stroke volume Vs equals to pi by 4 d square into L. So now substituting the value of d and L, that is pi by 4 into 0.15 square into 0.25. The stroke volume, the value of the stroke volume becomes that is 0.004418 meter cube. This is the value of the stroke volume. Okay, so the total cylinder volume, that means V1. So V1 is the summation of V1 is the summation of Vc, that means the clearance volume. V1 is the summation of the, so the V1 is that is Vc plus Vs. So the value of V1 is 0.004818 meter cube. The in this question it has said that the volume at point of cutoff, that is V3, is equals to, okay, in a here in this question it said that the fuel injection takes place at constant pressure for 5% of the stroke. Okay, so the value of V3 becomes the clearance volume, that is Vc, plus 5% of Vs. Okay, this is the value of V3. So Vc is the value of V2. That means this 0.0004 plus 5% means 0.00 0.05 into the stroke volume, that is 0.004418. So V3, the value of V3 is 0.0000621 meter cube. Okay, so the cutoff ratio is RC equals to, the cutoff ratio is equals to V3 by V2, and the ratio becomes 1.55. okay, the compression ratio, that is R means that is V1 by V2, and that becomes 12.04. this is the compression ratio. So the value of efficiency is eta equals to 1 minus, in numerator, RC to the power gamma minus 1, in denominator gamma into compression ratio to the power gamma minus 1 into RC minus 1. Okay, so now substituting all the values in this equation. Oh, sorry. 1 minus, the value of RC is 1.55 to the power 1.4 minus 1, gamma value is 1.4 into R is 12.04 to the power gamma minus 1 into 1.55 minus 1. So the efficiency 0.593, that means 59.3%. this is the value of the efficiency. Thank you. Okay, students, the next numerical is also on diesel cycle. Here is a numerical. The engine with 200 mm bore and 300 mm stroke works on diesel cycle. The initial pressure and temperature are 1 bar and 27 degrees Celsius. The cutoff is 8% of the stroke. Find number 1, pressure and temperature at all silent points, efficiency of the engine, mean effective pressure, and the power of the engine if working cycle per minute are 380. Assume that the compression ratio is 15 and working fluid is air. So this is a PV diagram of diesel cycle. This is 1, 2, 3 and 4. Okay, the cutoff takes place 8% of stroke. The cutoff is 8% of stroke. So 8% cutoff takes place at 2 to 3. So 8% of stroke. Stroke is 1 to 2. These are the dotted line shown here. This is 1 to 2 is the stroke, and 2 to 3 is 8% of stroke volume is the cutoff. So let's start. The dia D board dia is 200 mm or 0.2 meter. Stroke length 300 mm or 0.3 meter. the initial pressure P1, that means the pressure at point 1, is 1 bar. Temperature T1 is 27 degrees Celsius, that means 300 Kelvin. 300 Kelvin. Okay. Cut off, that is second, cut off is equals to 8% of Vs. Okay, that means 0.08 Vs. This is cut off. So the first question, that is, find out the pressure and temperature at all silent points. That means find the pressure and temperature at point 2, 3 and 4. So let's first find out the stroke volume, that is Vs is equals to pi by 4 d square into L, that is pi by 4 into, so pi by 4 into the d value is 0.2 square into L. L is 0.3, so the value of the stroke volume is 0.00942 meter cube. Okay, now the V1 is clearance volume Vc. This is the clearance volume, this is Vc plus Vs, this is V1. This total volume is V1, Vc plus Vs. Vc plus Vs is equals to, we don't know the value of Vc actually, the clearance volume, so we can modify it. We can write Vc as Vs by compression ratio minus 1 plus Vs. Okay. Okay, so now taking Vs as common, that is Vs into 1 plus 1 by R minus 1. So V1 equals to Vs into R by R minus 1. Okay, so value of V1 becomes, now substituting all the values of, that means Vs and compression ratio R is 15. Okay, now substituting all these values, 0.00942 into 15 by 15 minus 1. Okay, so the value of V1 becomes, 0.0101 meter cube. Okay, this is the value of V1. One thing, to find out the pressure and temperature in the silent volume, in the silent points, let's describe the value of clearance volume, how to find out the value of clearance volume, or how to derive the value of clearance volume in terms of stroke volume and the compression ratio. First of all, we know that the stroke volume, that is Vs, is equals to V1 plus V1 minus V2 is the stroke volume. We all know that. Now taking common the V2, so that becomes V1 by V2 minus 1. This V1 by V2 is the compression ratio, that is R minus 1. This is V. And V2, we can write V2 as Vc. This is the clearance volume. V2 is the Vc, the clearance volume. So we can write Vc is equals to Vs by R minus 1. This is the expression. Okay, the expression of Vc in terms of Vs and R. Okay, so uh, for the adiabatic compression process, that is from 1 to 2, from 1 to 2 we can write P1 V1 to the power gamma is equals to P2 V2 to the power gamma. So the value of P2 is equals to uh, V1 by V2 to the power gamma into P1. So V1 by V2 is R. That means the compression ratio. So R to the power gamma into P1. So P2 becomes 15 to the power 1.4 into the value of P1 is 1. So 44.31 bar. P2 value is 44.31. Next, the temperature and volume relation, that is T2 by T1 is equals to V1 by V2 to the power gamma minus 1. So T2 equals to T1, V1 by V2 is R, that is T1 into R to the power gamma minus 1. So the value of T1 is 300 into 15 to the power 1.4 minus 1. So the value of T2 becomes 886.2 Kelvin. Okay. Uh, the value of okay, this is the value of T2. The value of V2 from this relation. From this relation we can find the value of V2, that is Vc equals to V2 is equals to Vs by R minus 1. Okay, so we can write Vs is 0.942 by 15 minus 1. Okay, so V2 value is 0.0006728 meter cube. This is the value of V2. Okay, so let's find the volume V3. Cutoff ratio, we know that the cutoff ratio is RC. RC equals to the cutoff ratio RC equals to V3 by V2. The cutoff ratio RC is V3 by V2. V3 by V2. So V3 value is 8% of the stroke volume. Cutoff takes place 8% of the stroke volume, that is Vs, plus the clearance volume, and V2 is, the clearance volume. So by substituting all these values, the V3, the cutoff ratio value comes 2.12. This is the value of cutoff ratio. Okay. Also, from this relation, the numerator relation, that is V3 is equals to 8% of stroke, that means 0.08 into stroke volume, plus Vc. We can find the value of V3, that is 0.001426 meter cube. This is the value of V3. Okay. Now considering the process 2 to 3. Considering the process 2 to 3. 2 to 3 is the constant pressure process. So from the ideal gas law, that is P1 V1 by T1 equals to P2 V2 by T2, from this relation we can simply cancel out the pressure. So we can write this, that is V3 by T3 is equals to V2 by T2. We know all these three value, so we can easily find out the value of temperature. So T3 becomes T2 into V3 by V2. So V2 value is the T2 value is 88.6.2 into V3 value is 0.001426 V3 value, and V2 value is 0.0006728. Okay, so T3 becomes 1878.3 Kelvin. This is T3. Okay, this is T3. So we have P3 already known. Because P1, P2 and T2, these two are the constant, so P2 value is the P3 value. P3 and P2 are the same because 2 to 3 is the constant pressure process. In diesel cycle, 2 to 3, this is the constant pressure process. Okay, so value of P2 and value of P3 are same. P2 equals to P3. Okay, so these two are the same. So value of P2 is 44.31 bar, and this is also equals to P3. So P3 equals to 44.31 bar. Okay. So let's consider the process 3 to 4. Consider the process 3 to 4. For 3 to 4, it's an adiabatic expansion process. So the relation is P3 V3 to the power gamma equals to P4 V4 to the power gamma. Okay. Again, the P4 equals to, the value of P4 equals to P3 into V3 by V4 to the power gamma. Here this is a small thing, that is V3 by V4. We can write, sorry, V4 by V3. Let's reverse it. V4 by V3, we can write V4 by V2 into V2 by V3, and this V4 is equals to V1. So V1 by V2 into V2 by V3. Okay. So V1 by V2, we know that this ratio is called compression ratio, and V3 by V2 is cutoff ratio. So this is reciprocal of the cutoff ratio, V2 by Vc. So the value of V4 by V3 becomes compression ratio by the cutoff ratio. The ratio of compression ratio and the cutoff ratio. So value of P3 is 44.31 V3 by V2 is actually by RC to the power gamma. Okay, so R by RC to the power gamma is actually, that is 7.07 to the power 1.4. This is P4, and the P4 value is 2.866 bar. So so P4 value is 2.866 bar. Okay, now for the temperature and volume relation, T4 by T3 is equals to V3 by V4 to the power gamma minus 1, and that is equals to 1 by 7.07 to the power 1.4 minus 1, and T4 becomes T3 into 1 by 7.07 to the power 0.4 by subtracting, and T3 value is 1878.3 by 7.07 to the power 0.4, and the value of T4 is 858.38 Kelvin. This is the value of T4. Okay, now the value of V4 and V1, these two values are same, so 0.0101 meter cube. Okay, so we have already find out the value of temperature, pressure and volume in the silent points. Let's find out the value of efficiency. Okay, so we know that the efficiency formula, that is eta equals to 1 minus cutoff ratio to the power gamma minus 1 by gamma into compression ratio to the power gamma minus 1 into cutoff ratio minus 1. This is the formula of the efficiency, diesel cycle efficiency formula. So 1 minus, by substituting all these values, the cutoff ratio value is we have already find out the cutoff ratio value, that is 2.12 to the power 1.4 minus 1 gamma value is 1.4 into 15 to the power 1.4 minus 1, 2.12 minus 1. So the efficiency 0.598 or 59.8%. This is the efficiency. So and question number 3 is find out the mean effective pressure for diesel cycle. The formula for mean effective pressure in case of diesel cycle is P1 into compression ratio to the power gamma within third bracket gamma into cutoff ratio minus 1, okay, minus compression ratio to the power 1 minus gamma, compression ratio to the power 1 minus gamma into cutoff ratio to the power gamma minus 1 by in denominator gamma minus 1 into compression ratio minus 1. So the mean effective pressure, this is the formula of the mean effective pressure, and by the substituting all the values into this equation we get 7.424 bar. This is the value of the mean effective pressure. Now the power power of the engine, that means first we have to find out the work done per cycle. Okay, so work done per cycle so work done per cycle is this is mean effective pressure into the stroke volume. So the mean effective pressure is 7.424 bar. Okay, 7.424 bar. Let's convert it into Newton per meter square. That means multiplying it by 10 to the power 5 into the stroke volume, that is 0.00942 by 10 to the power 3, that means that is kilojoule per cycle. Okay, so the value becomes 6.99 kilojoule per cycle. Okay, so now find out the work done per cycle. Work done per cycle, that means the work done per second. So work done per second, that means the power, that means P equals to work done per second. Work done per second is equals to work done per cycle that means 0.699 into 380 by 60. So that becomes 44.27 kilowatt. This is the value of the power, okay, the power of the engine. Thank you.